this is topic 54, antiderivatives or indefinite integrals. So we're actually going to go the opposite way. So we're going to start with a function, and instead of taking the derivative, we're going to go backwards. All right. So let's talk about this table right here. If I take a derivative and I get a 0, if I take a derivative and I get a 0, then that must mean that this was a constant, right? So if f of x was a constant, the derivative would be 0. It doesn't matter what the constant is as long as it's a constant, right? Like a 4, a 5, a pi, 15, whatever. Alright, now if I take the derivative of f of x and I get a 1 for the derivative, that must mean that this function was originally x. Okay? Now if I take a derivative and I get an x, alright, to be precise, x to the first power. Now remember that the derivative is 1 degree less, so this original function must be 1 degree more. So if this is x to the first, this is x to the second. Right, but think about it, if I have this right here, if I take the derivative of this, I get 2x. I don't get just x. So what I can do is I can divide by 2. Alright, so notice that if I take the derivative of this, 2x divided by 2, I get x. Alright, the very next one, if I have x squared, if the derivative of a function is x squared, then the original function, it must be 1 degree more. Right, but again, on this one, if I take the derivative of x cubed, I would have 3x squared. Alright, but I don't have a 3x squared here, I just have an x squared. So that must mean that I divided by 3. Alright, similarly, on x cubed, if I take the derivative and I get an x cubed, then my function must have been 1 degree more. And also I divide by 4 because notice that I don't have anything here. So if I take the derivative of this, I get x cubed. So can you recognize the pattern? Alright, so to take the antiderivative, alright, what you do is you add 1 to this power. So you graph that function, add 1 to the power, and you're going to divide this function by whatever power you had up here. So that would be that. And also, they could be a constant value. You don't know that. The constant value could be 0 for all you know. There could be a constant value because remember, what is the derivative of a constant? The derivative of a constant is 0. Alright, so, and I can say the same thing for the rest of these. All of these could have had a constant number with the function. The answer is you don't know, but you must assume that there's always a constant there, because if you take the derivative of a constant, it's 0. And again, if that doesn't make sense, then go back, take the derivative of this. The derivative of x is 1, the derivative of a constant is 0, so you get back to this, okay? So in general, by the way, this is a symbol for the antiderivative or the integral. So a lot of the times most people call it integral. So this is the integral, so this is the integral of some function. Alright, that's with the symbol. And you're always going to write the plus c because you don't know if there's a constant around there. So let's look at some basic integration rules. So on this one, I'm not really typing too much. This is the general formula. One more time. This is the general formula that we come up here. Right? So the derivative of some function with respect to x would be add 1 to the power and divide by that same power and then add a constant. You have to add that constant. If you don't add that constant, I'm going to count it wrong. Okay, so let's go over it. The integral of 0 would be a constant, as we just talked about up there. And this kind of looks like it's nothing here, but you have to assume there's a 1, so the the antiderivative of 1 with respect to x would be x plus c, where c is a constant. Number 2, if you have a constant, if you're integrating a constant, then your answer would be kx plus c, where k is that same constant you had here. You basically just add an x to it. So the antiderivative of 5, for example, would be 5x plus c. Alright, and number 4, if you have a constant, if you're taking the integral of a constant times a function, you can take that constant out of the integral and then just take the integral of this alone without having to worry about this, right? So we're just pulling that constant out. Alright, I think one of the most important things then, this rule right here, if you're taking the integral of a function plus or minus another function, you can split that up into two separate integrals. Alright, so let's go ahead and do some examples, because I'm sure that you didn't get a whole lot of that of me just talking about it. So let's look at example 3. Alright, so in example 3, before I take the integral of this, or the antiderivative, what I'm going to do is I'm going to rewrite this as x to the negative 2 dx. Remember, if it's on the bottom, I can bring it to the top, and that would be a negative exponent. Alright, so I'm going to do the same as what you just talked about, right? Remember, what I said was that you're going to add a 1 to the power, and then you're going to divide by the same number that I get up here, which hopefully you can see it's negative 1, but say you can't see it, there it is. Alright, so that's how you do that. And then you have x to the negative 1 over negative 1 plus c. Alright, remember, I don't want a negative exponent here, so I want to simplify this, and if I simplify this, I would have 1 over x to the first power plus c, negative. And that negative just came from the denominator of this part, right? So that's going to be a negative. Let's see. Now the next one is it's going to be the same idea. I'm going to write this, I'm going to simplify this a little more. I have x to the 1/2 power, taking the antiderivative. I'm going to split this up, or I'm going to use a rule, I believe was number 5, to split that up. Yes, rule number 5. I'm going to split that up into two different intervals. And also notice that this right here, this 1/2 is a constant, right? I can actually pull that out. So I'm going to pull that out, and I'm just going to take the integral of 1 over the square root of x, which I can rewrite as x to the negative 1/2. Alright, so this is pretty algebra heavy. Make sure you're ready. Alright, so now once you have done that, which hopefully is the hard part, then all you do is the same process as what I did on example 3. You add 1 to the power. If I add 1 to this, 1/2 plus 1 is 3/2. So I have x to the 3/2. And I'm going to divide by 3/2. On this one, I'm just going to put that 1/2 right there, just move that down, and I'm going to take the integral of this. Negative 1/2 plus 1 is x to the 1/2, and I'm going to divide by 1/2. Okay? Plus c. You have to put the plus c, you have to. Alright, now if I divide this, if I divide by 3/2, if you do the keep change flip, that's the same thing as multiplying by 2/3. So I have 2/3 x to the 3/2 plus x to the, oh yeah, this is going to cancel. This is nice. The 1/2 and this 1/2 they're going to cancel each other out here. So this is just x to the 1/2 plus c. Alright, so that's my answer. Again, in general, if we're doing this, you don't want to leave any negative exponents. If you have any negative exponents, make sure to simplify further. Alright, on example 5, there's not really a way for you yet to try to take the integral of this of a rational function. So what you do here is you need to try to simplify where you don't have a rational function anymore. And on this one, I can divide this. I can just rewrite that as two separate functions here. So x to the 1/2 divided by x squared, that's going to give me, let's see, that would be 1/2 minus 2. So that would be x to the negative 3/2. Again, be careful with your fractions. Plus 1 over x squared, that's just x to the negative 2. dx. Right, and then normally what happens is that I'm actually just going to take the integral of this and take the integral of this separately. I don't need to worry about it. Yes, this is the same thing as you writing this completely separate, although to be honest, if I see something like this, I don't even bother to simplify to this. Just because I feel like that's just writing that it's a waste of time. Alright, so I'm going to take the integral of this, I'm going to add 1 to this. So I would have x to the negative 1/2 divided by negative 1/2. Plus, if I add 1 to this, that would be x to the negative 1 over negative 1 plus c. Okay? And then now This would be, let's see, divided by negative 1/2 is the same thing as multiplying times a negative 2. So I have negative 2 x to the negative 1/2. This would be minus x to the negative 1 plus c. But I want to simplify it. I don't want to leave any negative exponents, so therefore I'm going to write the answer here. I have negative 2 square roots of x minus 1 over x plus c. So this would be your final answer right here. Okay. So in case you don't know what I was saying here, how do I get to that? Okay, just understand that what I'm doing here is I'm dividing each one of these terms by x squared. So this would be x to the 1/2 minus 2. That's how I got the negative 3/2. And on this one I have, 1 over x squared. So this is negative 3/2, and this is x to the negative 2. Right, so this is how I got what I got here. So maybe I went too fast, I'm sorry. Alright, example 6. Again, there's no way for you right now to try to take that integral as it is. So what you're going to have to do is you're going to have to FOIL this. Okay, so if I FOIL this, I get 9x squared plus 30x, plus 25 dx. And then yes, you're going to take the integral of each one of these individually. Alright, so you're going to take the integral of each one of those individually. So this would be, the 9 just came from that 9, alright, I'm not doing anything with it. I'm going to add 1 to that power, and I'm going to divide by the same power. On this one, I'm going to add 1 to this power. Now this is a power 1, so I have 30 x squared over 2. Plus, if you have a constant, all you're doing really is you're adding an x. That's all you're doing. Because think about it, if I take the derivative of 25x, that should just give me 25, alright? And finally, plus some constant. Or again, you have to write that constant. Just to simplify this further, let's divide. So I have 3x cubed plus 15x squared plus 25x plus c. There's nothing else. Alright, finally on example 7, this is simple. There's no need to simplify anything. Let's just take the integral as it is. So remember, I'm going to add 1 to this power. So I guess that should be a 5th power here. Sorry, let me erase that. It's kind of messy here. Come on. There's a mess there. That doesn't look any better. Over 5 minus 8x. Remember, this is to the power of 3, so I'm going to add 1 to the 3rd power. Right, on the 9, I have 9x cubed divided by 3 minus 2x. Now, if I add 1 to that power, I have 2x squared over 2 plus 7x plus c. And now I just simplify that. So this is going to give me x to the 5th minus 2x to the 4th plus 3x cubed minus x squared plus 7x plus c. Alright, that's it. I hope that wasn't too confusing for you. If you have any questions, please let me know.